Okay, guys, how are you again? Hybridization. As you can see, multiple orbitals can combine to form hybrid orbitals. As we talked before, Vespa theory is useful for explaining the shapes of molecules, but it doesn't reveal the relationship between molecules geometry and the orbitals occupied by its bonding electrons. And to be able to understand and explain the orbitals and the arrangement of electrons to form the covalent bond, we used another model which is called hybridization, which is the mixing of two or more atomic orbitals of a similar energies on the same atom to produce new hybrid atomic orbitals of equal energies. So hybridization means that we are talking about two orbitals in the same atom. For example, when we talk about carbon, we know that carbon is 1s2, 2s2, 2p2. This is the valence shell S and the valence shell P. Both of them are located in the same energy level, which is 2. So in this case, we have 2s2, which is one orbital, and we have 2p2, but we have 3 orbitals. And this is the electronic notation for carbon. Now, what we mean by hybridization? Hybridization means that the orbitals here will be merged together to form 4 orbitals with exactly the same energy level. And because we have here one s, this is one orbital from s, and we have 1, 2, 3, 3 orbitals of p. So the type of the hybrid orbitals will be sp3. And the electrons will be located in the 4 orbitals. So instead of having 2 electrons in the s here, in the s orbital, this electron will be moved to fill the orbital here and form 4 orbitals, and the type of each one will be sp3. So we don't have s orbital anymore, and we don't have p orbitals anymore, but we have 4 orbitals with the same type, which is sp3. And this hybridization actually happened in the compound like CH4. So C will have 4 orbitals of sp3, 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 and sp3. And hydrogen contains only one s orbital. So the overlapping will happen between hydrogen here and carbon to form the covalent bond. So as we said before, here mixing of 2 or more atomic orbitals, which s and p, this s and the 3 p's here, they will be mixed together to produce a new hybrid atomic orbitals of equal energies. So instead of having s2s and 2p, we will have sp3, 4 orbitals of the same type, which is sp3. So as you can see here, this one, the 2s, merged with the 2p to form 4 orbitals with the same energy. It is less than the P energy, but higher than S energy, and form 4 sp3 orbitals of the same energy. So the hybrid orbitals are orbitals of equal energy produced by the combination of two or more orbitals on the same atom. So remember guys that we are talking about this process inside the same atom. So the hybridization is mixing of orbitals in the same atom. We aren't talking about mixing between two different atoms. And all the produced orbitals will be identical in shape and energy. They will be exactly the same. Now, as we can see here, the bonds formed by overlapping of the SO and S orbital of hydrogen, and this is the S orbital of hydrogen here, and this is the sp3 orbital. As you can see, the sp3 is a result of S and P. And remember that S shape is like this, and this is the S orbital. So it will be as if it has this shape, or simply this shape, because this side is mixed between S and P. So this will be bigger than this side here. So this is sp3, sp3, and this one is sp3, and here we have sp3, and this is the hydrogen s orbital connected to sp3 carbon hybrid orbital to form the covalent bond. Now, the hybrid type can give us the geometry of the shape. So if we have sp orbitals or sp hybridization, that means that we will have a linear shape. If we have sp2, that means that we will have trigonal planar shape. And when we have sp3, we will have a tetrahedral shape. So for example, let's talk about BCl3. B with atomic number 5. It will be 1s2, 2s2, 2p1. So the hybridization here will happen between S and P. And remember that here we have the 2p, 1, 2, 3, and for 2s we have 1. So we have 1 electron, 2 electrons here, and only 1 electron here. Now in this case, the electron moves from S here to fill this orbital. So the new shape will be 1, 2, 3, 4, 1, 2, 3. Remember that we took 1 orbital from S and 2 from P. Now the third one here is empty. So we didn't use this orbital here. So we have only 2p and 1s. So the total will be sp2. So this is the hybridization of boron, sp2. And because the hybridization of boron is sp2, so boron is connected with 3 chlorine atom. One will be shared here, and the other one is here, and the third one is here. So we have sp2. That means that we have triagonal planar shape, as we can see. I know it will be a little bit confused for you, but imagine that if we have sp, take it as we have two atoms, so we will have a linear shape with degree of 180. If we have sp2, sp2 means that we have 2 plus 1, which is a 3. So we have a 3 atoms. So we will have triagonal planar with 180, 120, sorry, 120, 120 degree. And if we have sp3, that means that we have a 3 plus 3p plus 1s, well, that means that we have 4 atoms. So we will have a tetrahedral shape. Now, actually, hybridization is a very wide subject, and we are not going to study all the cases of hybridization here in this chapter. But here we're just going to talk about it in a general way. So I hope, guys, that you just take the general information about the meaning of hybridization and take it as it is. Thank you and be safe.